Hello dear students, today we are going to discuss one more important questions for your next board examination or normal year conceptual growth. The question says that f is a function from natural number to natural number which is defined by n+1 by 2 when n is an odd number and n by 2 when n is an even number, and that is defined for all natural numbers. We have to state whether the function is bijective or not. You know that what is the meaning of bijectiveness? Bijectiveness means if a function is both on 1 and on 2, then we can say that the function is bijective. If it is not, then in that scenario, if any one of the condition doesn't hold, then we can say that it is not an bijective function. Let us check one after another. First, we will check 1 function. Already we have discussed in the previous question that what is the condition of saying 1 function. A function is said to be 1 if we know that f of x1 equals to f of x2 implies x1 equals to x2. That means if two points have the same image, then we can say that the points are actually the same. Now for this function, we are taking 2 points, x1 which is equals to 1 and another point x2 which is equals to 2. Why I am taking counter example, you will get that idea very soon. That now as x1 is an 1 and we know that 1 is odd function, then as per the function's definition, f of x1 will be x1 plus 1 by 2. That is, the first condition will satisfy. First condition says that if odd number is taken, then plus 1 by 2 is the function's output. Now, so that will give us x1 is 1, so 1 plus 1 by 2, which is 2 by 2, that is 1. So we can say that f of x1 equals to 1, that we are getting. Now, if we take f of x2, that means x2 is a point which is 2, that is an even number, then definitely function will satisfy the second condition. Now in second function's condition, it gives us the output n by 2. In our case, n is x2, so x2 by 2, x2 is 2, so 2 by 2 which is giving 1. So f of x2 we are getting 1. Now we can easily understand that f of x1 equals to f of x2. Now all you know that to become 1 f of x1 equals to f of x2 should imply x1 equals to x2. But in our case x1 is 1 and x2 is 2. So we can clearly say that x1 is not equal to x2, that is violating the condition of an 1 function. So we can clearly say that this function is not 1. You can take different pair of example as well. Take any two consecutive numbers, natural numbers definitely, because our domain is natural number, or I am taking any other two consecutive numbers, supposedly 3 or 4. For 3, as 3 is an odd number, the output will be 3 plus 1 by 2, that is 2. And whenever we are taking 4 is an even number, the output will be 4 by 2, which is also 2. So we are observing two numbers we have taken two different numbers, but the output becomes same. So again, this is not an 1 function. So multiple example we can consider. This is one of them. But whenever we are talking about the ontoness of the function, let us jump into the ontoness of the function. What ontoness says that every element of the codomain. So this is the codomain. We all know that codomain, which is also given as natural number, and domain, which is also given natural number. That is a function defined from natural number to natural number. The function is defined. So ontoness says that every element of codomain must have a pre-image. Whatever the image point we are taking from the codomain, it must be connected to at least one of the point. Now, if we observe the function's condition, just we have discussed in the case of uh, 1 to check the 1 of the function. If we observe carefully, you will get a clear idea how the function is acting. So whenever we have taken 1, the output goes to 1. Even if we are taking 2, the output goes to 1, because 2 by 2 is also 1. Again, whenever I have also shown for the case of 3, it goes to 2. For the case of 4, again it goes to 2. So what we are observing, so if someone takes 5, it will go to 3. If someone takes 6, that will also go to 3. So what we are observing, for every natural number on the right hand side, it is the codomain. It is the codomain part. For every natural number of the codomain, there are at least one. Actually, we are getting two pre-image on the domain said. Now that is the observation, but how theoretical we can say that, because the process whenever you are showing in examination, it says that whenever something is not true you can give counter example, but whenever something is true, in that case you have to take the theoretical approach. So we can say that whatever the natural number, so what our purpose is to show onto function, if we take any point k from the codomain, there must have at least one preimage. Now we can say that if we take k on the codomain, k belongs to natural number which is in codomain, we can say that as k is a natural number, definitely twice k implies twice k also belongs to natural number. Now we can consider that twice k, because any natural number multiplied by 2 is also a natural number, so that there is no doubt in this scenario. So twice k also a natural number. Now we can consider that this twice k actually belonging in this domain, because domain is also a natural number. What that will help you? Now we know that as twice of k, any number is in the form of 2k, we know that an even number, and our function says that f of n equals to n by 2 when n is even number. So in that scenario, as twice k is even number, so if we take f of twice k, that will give the output twice k by 2, which is k, and that k is in our codomain. So we can consider that for every k on the codomain, there exists one point 2k on the domain part, which has, that means every point of codomain has an preimage. So there are also different way. Now you can also say that how we can get that other one. Also it is not our case. Whenever we are showing a function is on to at least one preimage, if we are getting, that is well and good. Now if you wish to get the another one, that another one also we can set up the another one that can be achieved by 2k minus 1. So let us take 2k minus 1. What is 2k minus 1? Now if k is a natural number, twice of k is also a natural number, and if we subtract 1, it will still be a natural number, because k is natural number means k's minimum value is 1. So if we take minimum value 1, then 2 into 1 minus 1, which is positive. So there is no problem. If it was negative, then it would have been a problem, because our domain does not contain the negative values. But in our case, as k is taken as natural number, so 2k minus 1 is also natural number. Now it is clear that for any value of k, 2k minus 1 is an odd number. Now also again, if we observe the function's definition, it says that f of n equals to n plus 1 by 2 when n is odd. Now, as our case 2k minus 1 is odd, so whenever we try to find out f of 2k minus 1, it will give 2k minus 1 plus 1 by 2. So minus 1 cancel, plus 1 cancels out. So 2k by 2, which is k, that is the point of codomain. So again, we are getting the other point. So for counter example, whenever we have taken k equals to, supposedly I am taking k equals to 5. So whenever we have taken k equals to 5, one of the preimage we can take as 2k, that is 10. Another preimage is 2k minus 1, that is 10 minus 1, that is 9. So if we take either 9 or 10 from the codomain, if we take either 9 or 10 from the codomain, both of them will be connected to k. So k means, in our sense I have taken k as 5. So in our sense 5 will have two preimage. Actually for the case of 1 2 we need one, but here we are getting more than one. So hopefully you have understood why this function is not 1 1 but on 2. So our final conclusion, is it bijective? So it is not bijective. It is not bijective, because bijectiveness required both 1 1 and on 2, but here only on 2 satisfied, but 1 1 does not satisfy, right? Thank you.